What's up, everybody? Um, it's Blake Green here. Okay, gonna continue to go through the AWS Amplify and CDK workshop. Last time we left off, we kind of set up the organization of the front end and back end uh, of the project, and then we're going to continue on through creating the or adding the GraphQL schema. Um, and GraphQL is like kind of a new technology to me. I think it's still pretty early days with it as well, but uh, for another resource that I really enjoyed learning on Hashnode, um, there's this article by Rishav, and it's called Learn GraphQL in 7 minutes, and it really goes through some great details of what is GraphQL and how it kind of differs to traditional like REST APIs. And specifically, it says GraphQL is for APIs as SQL is for databases. So it's a new API standard that provides a more efficient, powerful, and flexible alternative to REST. Yeah, so I mean, it's kind of an interesting article here. It kind of dives into three main components of what makes up GraphQL, as far as like queries, mutations, and subscriptions. And then there's like some sample code that it goes through, kind of describing each of those components, I guess. But yeah, good. It's a good resource to kind of read through before we jump into adding the GraphQL schema into our project. But as far as the workshop is concerned, the next step here is where we define the GraphQL API, and we set the schema directory, and creating like a local file for our CDK app to use. So we just need to create. I think we're still in the backend, the next backend directory. Hopefully that's readable, but. Okay, so yeah, we did end up creating the file because when we did the CDK synth, it couldn't find that file, but I just left it empty and for us to pick up here. So okay, so first, first thing right off the bat is that we can see that the schema.graphql file contains these, different types, right? So the type post here, and then we specify the properties that we want to give it. And you can see like we're specifying the title is a string, right? And content is a string. So we know like what data type it is when like the schema is kind of the API documentation versus like REST where you kind of have to parse through it to kind of figure it out. This is kind of more of a strongly typed way to define your API. So pretty interesting stuff, right? So let's see. Input post. So we'll just copy this guy in here. Wonder if there's got to be like a GraphQL extension. Let's see if they can grab a GraphQL extension and get some syntax highlighting. This is probably, yeah. All right, so it gives us a little bit better like syntax highlighting once you install an extension for VS Code or something. But anyways, let's continue to go down. So type query. We're gonna get the post ID. Let's see. Type mutation. Okay, yeah. So like, we're using this query type to get like the post ID, list all the posts, post by username, and we're actually using the Cognito user pools to view like the authenticated username that created the post to query on that as well. And then the mutation is obviously would be our like the CRUD part of the API, right? So create post, delete post, update post. We can also create subscriptions on create post. So that will be interesting to. So I'm just going to copy this into our schema.graphql file. And here's some more additional documentation, which says, this schema defines the post type that we'll be needing along with all of the input types and operations for creating, updating, and reading posts. There's also authorization rule sets in place by using API key, the API key and Cognito user pools. The API key enables public access. And the user pools configures private access for users that are signed in. You'll notice that some of the queries enable both public and private access, while the mutations only allow private access. So that is because we only want to enable signed-in users to be able to update posts, and we'll even be implementing business logic that only allows users to update posts if they're the owner of the creator of the post. Very cool. Okay, so adding and configuring a Lambda function data source. Next, we'll create a Lambda function. The Lambda function will be the main data source for the API, meaning we'll map all of the GraphQL operations, including the mutations and subscriptions, into the function. The function will then call DynamoDB to execute of the operations we'll be needing for creating, reading, updating, and deleting items in the database. To create the Lambda function, add the following code below to the API definition in lib.nextbackendstack.ts. So we already have our, let me get rid of this here. So we already have our Cognito user pool client. There's our AppSync GraphQL API. And let's see. I'm assuming we could just add it towards the end. So here. me bump it up one size. Alrighty, so let's say const post lambda equals new lambda dot function. AppSync post. So the runtime will be lambda dot runtime dot node. So our handler will be main dot handler, and then code, we're going to give it the local file path, I believe. Dot code from asset, and then give it the name of the directory, lambda fns, memory size 1024. Oops. Const and these equals API. So now we're just adding the lambda function to our GraphQL API. So add. You gotta love these methods here that just make it so easy to connect. Connect multiple services together. I mean, lambda data source. Is that what he called it? And then we just pass in our post lambda. Give it a name, and then we pass in the lambda function. Cool. So now, adding the GraphQL resolvers will now create the GraphQL resolvers definition that will map the requests along coming into the API into the Lambda function. To create the resolvers, add the following code to the Lambda function definition in lib. Okay. So now we need to basically tie our data source to will map the requests coming into the API into the Lambda function. Okay. So these resolvers will map the requests coming into the API to the Lambda function. So we got query. Okay. So we're just trying to resolve, like, if a query comes in, the field name would be post by username, list post, get post by ID. Okay. Okay. I'm just going to go ahead and copy and paste that. Okay, so there's all of our resolvers now. Next, we'll create the DynamoDB table that our API will be using to store data. To create the database, add the following code to the GraphQL resolver definitions in the lib in our CDK app. So const post table equals new ddb dot table. This CDK post table right. So billing mode, make this like a pay per request. And then we have to specify the partition key, right? One of those required. Name equals ID. And then the type is a string, right? GDB attribute type string. Okay. Okay, then we add a secondary index. Oops. Post table dot add oops. Okay, so this should give us better code completion, right? So add global secondary index. Index name will be posts by username. And then that partition key, scroll up here a little bit. So that partition key, the name of it will be owner. Type is also a string. Okay. And then now we just need to add IAM permissions for the Lambda function to be able to interact with the DynamoDB table. Post. Right, yeah, so it says enable the Lambda function to access the DynamoDB table. Again, like just being able to use this method, right, like of grant full access. It says right here, it says permits all DynamoDB operations to the IAM principal. That's really convenient. Okay, and then lastly, we need to say post lambda dot add environment. So we add the environment variables that specifies the table name, I'm assuming. So this will be the key, and then the value will be post table dot, see if they specify, yeah, the table name. And basically that's just setting the environment variable that we'll use in the function code itself, right? So it says, this code will create a DynamoDB table and add a global secondary index to enable us to query the table by username field. We will also enable permissions for Lambda function we created earlier to be able to interact with the table, as well as the new environment variables that we'll be using to reference the table from within the function. Awesome. So printing out resource values for client-side configuration. If we'd like to consume the API from a client application, like we will be doing with the Next.js app, we'll need the values of the API key, GraphQL URL, Cognito user pool ID, Cognito user pool client ID, and the project region to configure our app. We could go inside the AWS console for each of these services and find these values, but CDK enables us to print these out in the terminal upon deployment, as well as map these values to an output file that will later import into our web or mobile application when we use AWS Amplify. To create these output values, add the following code below the DynamoDB table definition in our CDK app. Yeah, so this is like the bread and butter, right, of using the CDK for backend resources, and then outputting them to a file to consume those resources with the front end application through Amplify. This is pretty basic, like outputting of these values or exporting of the values to the CDK app. So like I said, we're just doing the GraphQL URL, the API key, or leaving it blank, the region, the user pool ID, and the user pool client ID. So I'm just going to copy and paste this. Pretty straightforward. All right. Really quickly, like before we get too far into the weeds, right? I want to just cd into next backend and then run a CDK synth to make sure everything's still on the up and up. Ooh. Oh, okay. So same thing that happened last time. It's probably, yeah, this next part here anyways. So we just need to create the directory for which the Lambda functions will live in, right? We called that directory lambda-fns for functions, right? So if I go in here and say lambda.fns, okay, so yeah, I guess that I got a little bit ahead of myself there, but because the next part here is adding the lambda function code. The last thing we need to do is write the code for the lambda function. The lambda function will map the GraphQL operations coming in via the event into a call to the DynamoDB database. We will have functions for all of the operations defined in the GraphQL schema. The Lambda handler will read the GraphQL operation from the event object and call the appropriate function. That's pretty cool. Create a folder named Lambda functions, which we just did, in the root of the CDK project, and then change into that directory and initialize a package.json file and install the UUID library. Alrighty, so get rid of this here, clear the screen. So if we cd into Lambda functions now, and we run npm init -y, oops, -y. Did that create a... Okay, so it did create a package.json file. And then we'll run npm install UUID. That's fast. In the Lambda FNs folder, create the following files. So we got a lot of different operations here. So it's going to be a lot of different files, right? So we'll go ahead and create main.ts. Just going to copy that. I don't know what's the fastest way to like add a bunch of files. I'm just gonna say touch create post.ts. List posts.ts. Get post by ID .ts. Delete post.ts. Almost had it. Delete post. And update post. And post by username. So we got it all. We got create post. We got delete post. We got get post by ID. List posts. Main.ts. Post.ts. Post by username. And update post. think that's right, but we'll keep going. Okay, so first one is post.ts. I'm going to get rid of this guy. And looks like we just export it looks a little off, right? Isn't it supposed to be all right, so the post type should match the GraphQL post type and will be used in a couple of our files. So the main.ts file now, basically we're just going to import all of our other operations. So I'm just going to paste that in. This should go away once we create the rest of the operations. But okay, so type is AppSync event info field name. So this AppSync event type is like the data that's coming into the Lambda function. Okay, and then here's basically some logic to pass, the data to the corresponding function. Because we get this switch statement here that so from the AppSync event, if the field name matches the string get post by ID, then it will return. I can't scroll over. Okay, so yeah, get post by ID. If it matches that field name, get post ID, return the post ID. Or yeah, okay. Okay, I mean that makes sense, right? Because it just kind of goes through like if the field name matches, these particular operations, then go into that function and get that, or perform that, action or operation. List posts just calls that list post function. It is kind of interesting, we're using the username from Cognito to, dig into these particular functions. That's pretty cool. Okay, so I'm just gonna copy and paste that. Alrighty, so the handler function will use the GraphQL operation available in the event info field name. So that would be this here that it gets passed in from the GraphQL API, right? And then to call various functions that will interact with the DynamoDB database. The function will also be passed an identity object if the request has been authenticated by AppSync. If the event is coming from an authenticated request, then the identity object will be null. Or maybe that's a typo, because it would be an unauthenticated request if it's, because the default would be return null if the user has already authenticated. But anyways, we'll test that later. All right, so next is create post. I'm going to type this one out because I have not used the SDK very often. So basically, we bring in the AWS SDK. Require client new AWS .dynamo db document client import post That's for like creating our unique identifiers in the ID attribute, right? And now we say async function. That's cool. Give us some nice autocomplete. Create post is the name of their function. And then post is type post. Username is a string. Right? So now that we're passing in those parameters of the post and the username, we say if it not post ID Oh, if there is no post ID equals it basically gives it a unique identifier. What is this actually like? No. Okay. And then we'll say const post data equals the post, the data from the post, I guess. And then the owner equals username. Const params. Okay. And then we pass in the environment variables that we set on our Lambda function. So table name equals process inv dot post table. Item equals post data. Okay. And then now we do a try and catch block. Say await for the doc client to put the parameters, the promise, and then return post data. Or catch the error and console log dynamo db error equals error. So we'll see that in our the lambda logs. Otherwise, return null. And now we just export this so that we can use it in our main .ts. Export default create post. Cool. So next is list posts, and we should see that create post is now able to be used. Okay, so list posts. We'll just bring these guys in. So we don't pass any parameters into the list posts because we don't need to be authenticated to be able to list the posts. Const params equals. So we need to again specify the table name from our environment variables. of our Lambda post table. Okay, and then we say try const data equals await doc client dot scan. Okay, so we're scanning the DynamoDB table for with the params. Process or proms. So it looks like we perform a scan on the DynamoDB table, which uses does it use the primary partition key? So we just scan all the the IDs of the. I guess it would scan both of the primary partition key and the global secondary index that we added to the DynamoDB table, but we'll check that because now we're basically returning the data from that scan items. Catch the error. Okay. Console log out. Log. Dynamo error. Just in case we need to look it up in our Lambda logs. And then we export default list posts. Okay, so the list post function scans the database and returns all of the results in an array. Okay, so then I'm assuming like on the front end when we update our Next.js application, we can just sort of parse through that data that is provided to list the posts in the application. So get post by ID. Bring those guys in. Async function get post by ID. So again, we're just passing in the table name, process.env post table. And then now we use the key for ID equals post ID. Okay. So now we do a try const item equals await doc client get params. Promise me you'll get the params. Okay, and then return item. Catch error. And console log. Cool. Making progress here. 3 more to go. So next is delete post. Delete post. Post ID is a string. So we're passing in the post ID, which is a string, and the username, which should be like the owner of the post if they wanted to delete it, right? Again, okay, so params are a little different this time. So const params equals, again, table name. So we're adding a condition expression here. Basically, I think that it's making sure that the user is the owner of the post before they can, call this function to delete the post. So expression attribute names. Expression attribute values. So that's how we're kind of tying the ownership of the post to the username. Right. Excuse me. And then now we say try. Okay. And then await doc client dot delete. Should that not be delete posts? Delete post? Oh, no. Oh, no, because we're saying that. Okay, sorry. That's for the to delete from the DynamoDB table. So basically delete that post ID if the owner matches the username. And promise. Turn post ID or catch the error. Console.log. And then just export default delete post. Cool. So update post. Bring in the SDK and the DynamoDB client. Okay, so params. Any post, but we need the username, which is a string. Let params equals. Okay, and then now we pass in table name process. All right, and then condition expression, hashtag owner equals expression attribute names. Okay, and then we can also add a return values. That's kind of nice. All right, and now, oh wait, we don't need that. Let prefix equal set. Let attributes equal object keys post. And then we create a for loop that says let I equal 0. I is then attributes dot length. All right, so it says let attribute equals attributes 0, index 0. If attribute does not equal ID, params update expression All right, so I don't want to, there's a lot of opportunity to create a typo here, so I'm just going to actually copy and paste this logic into here. But basically, I think what it's doing is saying, like, if the attribute does not equal ID, we need to update the expression. Oh, to set the owner. I'm not exactly sure what that's doing. Okay, we'll keep going. Maybe we can look through the Lambda logs after we get this deployed, but basically we just need to add our try catch at the end and then export the update post. So it says there's a lot going on here, but I'll outline the two main things that may trip you up when you're looking at this code. Okay, yeah, so there's a condition expression that will only allow the update to succeed if the owner fields match. Okay, meaning that the user who is trying to make the update needs to be the user who created the item, or this will fail. This is how we implement fine-grained access control on this item. Number two is there is logic that will update the update expression dynamically based on what is passed in. This way, we can allow the user to update n number of items without having to take into consideration how many items are being updated. Interesting. Yeah, I'm definitely curious to look through the logs at the end or after this gets deployed and we, try to update something, see if we can look into that a little bit deeper to see what happens. But we'll keep going here. Post by username. So I think this is our last Lambda function that we're creating. Maybe not. Okay, so just gonna take a look at this here. It's just another function that we get the table name. The index name is post by username, which I think was this global secondary index that we created. And then it basically is parsing the owner attribute and assigning it to the username. And then kind of the same things here that, we're trying to get the parameters and then return the items from the DynamoDB table. So pretty straightforward there. I'm just going to go ahead and copy and paste this one. I think this is formatting properly like on the copy paste, but we'll see. All right. I think we are, wait, there's an error in here. Oh, that does not look right. So we're at get post by IDs. Where is that one at? There we go. Alrighty, everything else looks green so far. So I think we did it right, but we'll see. Okay, so to see what will be deployed before we make any changes at this time, we can build the project and run the CDK diff command from the root of the CDK project. So we'll just copy this. Note that if you run this command from another location other than the root of the CDK project, it will not work. At this point, we're ready to deploy. Okay, so let's run this command first and and see, because I don't think we actually deployed the Cognito resources yet either. But let me just open up a terminal here. Clear that out. And yeah, if we copy that in. Oh, duh, I'm not in the right directory, like it said. Okay, so now we are in the root of the CDK project. If we try that again, see what happens. Unable to resolve AWS account. Let me just try to reconfigure my AWS credentials. Oh no. Okay, let's see what happened here. And I've been battling with this AWS authentication for a while now. Darn it. Let me take a look at the let's try this again. So it says it's already installed. Seems to already be installed. Not modifying existing installation in the Linux brew. I guess I could try force. Sudo. Darn. Well, maybe that's a good spot to leave it. We can pick up deploying and testing now that we've kind of built out the backend with the GraphQL schema and Lambda functions with the resolvers. I think that's where I'm going to leave it, and we'll catch up again and continue to go through. It looks like we're about halfway through this workshop, so I think it's a good time to wrap it up, and we'll keep going through it at the next stream. So thanks for watching.